Why don't we recycle energy?
You're hitting the nail on the head. We would like people to be recycling their fuel in the same way as they recycle other things.
Your technology is we're going to refine that energy, that carbon, out of the atmosphere, combine it with hydrogen and water, and then that's the same as gas or jet fuel?
Yeah, it's chemically the same. No pollutants. So for example, our diesel burns completely clean. None of that black smoke you see from trucks when they go up hills.
Right.
Completely clean. But yeah, it's chemically identical. So this is our plant. Great to have you here. Everything here is a working model, full process working, and we are capturing CO2 from the atmosphere right here. Think of it as like a big cooling tower. Large fan, the fan draws the CO2 in, chemical reaction, and we capture the CO2.
Wouldn't there be more carbon to capture by dirty, naughty factories?
No, it's uniformly distributed.
So
we could
anywhere.
put one of these plants in the middle of Beijing, or we could
Right.
put it in the middle of the Sahara Desert. You would capture the same amount of atmospheric CO2.
So we as a species have put it in, so we as a species should be taking it out.
Well, that's our choice, but I think we have to, or find somewhere else to live. This is the fuel that we make. It looks exactly the same as any other fuel.
Right.
It's very, very high chemical performance.
Right.
Higher performance fuel than the stuff you buy at the pumps today.
So it's better than the pumps, it's carbon neutral, and theoretically it would be cheap to make because you're refining the energy that's already out there in the atmosphere.
Yeah, you're using the CO2 from the atmosphere. Your only feedstock, the only thing you're consuming is renewable electricity.
Right.
But here's the interesting thing, a carbon neutral fuel that's compatible with any vehicle in the world today.
Right.
So that car you just drove up in, we can make that carbon neutral tomorrow.
Wow.
Any vehicle, any performance vehicle, any battered old truck, aeroplanes, we're compatible with all of those. Which is significant because nobody's making electric tractors or electric planes.
Right. Do you have to do any modifications?
No.
Wow.
So transportation is about 20% of the CO2 emissions. How are we going to decarbonize that? There's 1 billion cars in the world. So if we all go electric, $50,000 for an electric car, that's $50 trillion. Then you got to deliver energy and electricity to each car. It's a massive change.
Yeah.
Alternatively, why don't we just change the fuel? The price to you at the pump will be the same.
Having something like a carbon neutral gas isn't even enough. We've got to start going negative. We've got to actually pull carbon out of the atmosphere. Now, can this do that, and what's the plan
You can
there?
take the CO2 generated here and bury that underground, and you get to negative emissions.
Right.
It's a hugely important thing.
And how many do you need to scale it to get to carbon negative?
You need less of these than there are power stations in the world today to net emissions out to zero.
And how many is that?
It's in the region of tens of thousands. If we are taking measures as we should be to remove emissions elsewhere, now you start getting to an overall negative emissions from the world.
Why isn't the world rushing to Squamish, BC and saying, can we please make 100,000 of these?
So first of all, we're open and ready to receive the world. Secondly, we've really just got to proof of concept here, and it's working. So the next step for our business is to expand across the globe, make carbon neutral fuel, and when the scientists and the governments decide that they need to do negative emissions, the technology's ready. It's simple. I have kids. I hope one day to have grandchildren. It's unreasonable that we should pass this problem on to our kids and our grandchildren. We have to solve this problem before it's too late. Carbon Engineering is a direct air capture company. We capture CO2 right out of the atmosphere. That way we can eliminate any emission from anywhere on the planet, but also any moment in time. And that's going to be a critical tool in the fight against climate change. So Carbon Engineering's technology works by pulling CO2 straight out of the air and putting it back underground again. That's where it came from in the first place. Or alternatively, we can make products like fuel, and that way we recycle the same CO2 over and over again. We do this using chemical processes and pieces of equipment widely used in other industries today. Together, that means that we can deploy this technology at large scale in many countries worldwide. So, where does direct air capture help with climate change? Firstly, stopping every single emission on the planet worldwide, it's going to be really challenging, time-consuming, and expensive to do. We're going to need every tool that we have in the toolbox. Electric cars, for example, are a fantastic way to decarbonize private vehicles. But what about airplanes? What about steel production? What about agriculture? These are industries that have a high carbon footprint. They're really difficult to decarbonize. If we can remove CO2 and put it permanently back underground, that's the same as stopping an emission. Secondly, climate scientists point out that we have a lot of legacy CO2, the CO2 we put into the atmosphere yesterday and the day before and all the way back. And no amount of electric cars, renewable electricity can deal with yesterday's emissions, but direct air capture can. So our technology has been developed over 10 years. Over the last 5 years, we've validated the performance of our technology in our pilot plant here in British Columbia. We're upgrading our facility to a brand new innovation center, and we're working with forward-thinking companies worldwide to bring this technology into deployment. Direct air capture technology is applicable for any location on the planet. Air is everywhere, so we can remove CO2 wherever it needs to be removed. In the United States, we're working with our development partner 1.5 to build the world's largest commercial DAC facility. It will capture 1 million tons of CO2 per year. That's the equivalent of 40 million trees worth of CO2 capture. In the UK, we're working with Storegga to bring direct air capture to the United Kingdom. The UK was the first major nation to announce net zero, and we're looking forward to building a plant in northeast Scotland, which will help address their climate obligations. I'm stood here in front of our innovation centre in Squamish, British Columbia. Carbon Engineering and its partners have been working to complete and finish this centre. When finished, our innovation centre will allow us to optimise our technology, increase its efficiency and reduce its cost. Direct air capture is feasible, affordable and available. For governments, companies, individuals trying to find a way to eliminate their carbon footprint, it's difficult. But by removing CO2 from the atmosphere, we provide a service that anybody can use at a price point that will make sense compared to many other alternatives. At this crucial time in our planet's history, climate action is needed now. Together, we can provide the next generation with what they need the most: hope.